Good morning and welcome back again. Today we have another section. We are talking about another way to solve differential equation. We mentioned before in chapter 2 that if we have a higher order but homogeneous, means that we have, for example, we have something like that in 2.1. In 2.1, if we have something, for example, we say y double prime minus y prime plus y 4y is equal to 0. If we have a homogeneous here, is equal to 0 is called homogeneous. And if we have, what do you say? If we have higher order, then we are going to use variation. We are going to use the methods that we have. For example, we use the M, if you remember, and we found the solution. And how many cases do we have? Three cases. Maybe they are like that. We say y equal to C1 M1x, right? Plus C2 E2 M2x. Or maybe they are equal. In that case, we call that C1 M1x plus C2x M1x. Why M1? Because M1 and M2 both are equal. Then we say that sometimes we have what? We have a complex variable because we use to solve. We try to solve it by quadratic formula or whatever we get. We got a complex value. In that case, when we got a complex value, of course, the important thing is what? Is to find which one is x, which one is alpha, which one is beta. So we use that. We say that if, for example, z equal to alpha plus minus I beta, we know what's I. I is coming from minus 1, right? So in that case, we say y equal to e to power alpha x, c1 cosine beta x, c2 sine beta x. Do you remember that? It was in 2.1. Now we are going to talk about another things for today. We have what? We are going to use variation for non-homogeneous variables. So we have a higher order, for example, but here we have things. We have a function. So this method is called variation. What do you mean variation? How we solve it? You can see from here, everything is clear for here. Talking about how to find it, how to summarize it, which things you need to control. What do you mean by that one? If I have, what's the standard form? We change to the standard form. You remember what's the standard form? Right? We use it. Then we will get two solutions is YC and YP, then general solution. So what's the YC? YC is auxiliary solution. What's the YP? Is particular solution. So today we are going to mention all these together. Now, after very standard form, we need to find, we are trying to find auxiliary one. So we are going to use the variation determinant W1, W2, U prime, U sub 1 prime, U sub 2 primes, then integrate this one. You will get many things here. All these things, all these steps is summarized here. I'm going to show you all this one in the example. We are going to apply our regular way, our methods with the example. Then we close the door. Thank you. So we are going to try here to get the way, or to get the method that we are going to talk about today. So here we are. You can see we have y double prime. Okay, good. Now I have y double prime. What else? As well, you have what? You have non-homogeneous, right? Is not equal to 0. So how we solve that one? You are going to use variation. Okay. Or parametric variation. So First of all, think about it. Change 2.2 in your mind to 2.1. What do you mean by that? I mean, think about y double prime minus, minus 4y prime plus 4y equal to 0. How we solved it? We did it before. You remember? We say that m squared minus 4m. Now, I can solve it by quadratic formula or as a complete square. Am I right? Up to you. Both of them will give you the same answer. So, I'll get what? I'll get m equal to 2. Am I right? Do not forget, this m is m1 and m2. So, it means that I have this, the second case, I have a repetition between what? Between the solutions, right? So, how is our solution in 2.1? How we describe our solution is clear for you. We say y equal to c1 e to power 2x plus c2 x e to power 2x. We are going to call this c as a yc. It's called auxiliary solution. It's not a real solution. Why? Because we change this function to be 0. You remember that, right? So we found the auxiliary solution. This solution will help you to find yp. Then I told you your general solution will be what? Will be yc plus yp. Good. So let me give you more things. Now, I'm going to call my variation, it's called Wronskian. This technique is called Wronskian. I'll call e to x, x e to x. I'm going to write my things like that. Is that clear, dear, for you? Good. So we are going to use the determinant. You saw that one, I think, before. E to power 2x. So this one for first column, that one together for the second column. Is that clear, dears? Hello? Good. Derivative, so for the first line. How about for the second line, for the second row? We are going to use the derivative. Derivative of e to power 2x is equal to what? 2 e to x. How about for the second one? Is the two functions multiplication. So x 2 e to power 2x plus e to power 2x. Am I right? First multiply the second derivative plus second multiply by the first derivative. Or derivative of the first. Is that clear, W? This is new for you. Clear? Good. Now we are going to find it. How we find the determinant? How we find it? Have you seen that one before? This absolute value? Okay, let me give you the clue. As for example, if I have W and I have A, B, C, D, that absolute value is called determinant. Yes. So we are going to multiply the main diagonal. We see is equal to AD minus second diagonal BC. Is that clear for you, dears? Hello? Shall I repeat it? No. So tell me, W is equal to what? Our W, that one. So I said W is equal to this one multiply the main diagonal. Am I right? Minus that one multiply the second diagonal. Clears? Good. So we are going to what? 2x e to power 4x plus e to power 4x minus 2x e to power 4x. The bases are equal. We are going to add exponent, right? Continue exana. Exponent can coquino. So I will get what? Awachi W. Is that clear, dears? Good. Now we have W1. We are going to find W1. You got W is what? Good. Now you are going to W1. Let me remember you that W, it was like that. Do you remember? So W1 is equal to what? W1 is equal to the same. Okay, dear, is that clear? Then we are going to put 0 here. And the function that we have in the standard form. What do you mean by that? I mean this function. You got it? So this is on the standard form, yes, and that one is my function. So I'm going to write x plus 1 e to power 2x. Okay. What's the column here, come on? Amen. W1 علي؟ اوكي W1 ديريفيتيف يكم ضرب داتا شاي دوم زائدا دوم زائد داتا شاي يكم أمين غلطهم كله yes thank you I just forget thank you there's nothing no worries that's for sure you got it here. Shall I repeat how to bring W1? W1, you are going to bring it, copy and paste from W, but you are going to what? To clean the first column, change the first element to 0, the second element to the function. How about W2? Can't find that one. W1, it will be what? 0 minus x e to power 2x multiply x plus 1 e to power 2x was equal to what? Minus x e to power 2x minus what? Or plus minus x e to power 2x. Am I right? You can use it, you can leave it. Up to you. Is that clear, dears? Good. So you multiply or you can leave it. I prefer to leave it. I don't want to multiply it, for example. I prefer to leave it. I say W1 equal to minus x e to power 4x x plus 1. Leave it. Maybe later there's elimination, I don't know. Yalla, tell me about W2. So I say W2 is W1 is W, but instead of here we have what? We have 0 and x plus 1 e to power 2x. Am I right, dears? Hello? Now, after multiplication, I'll get what? That one, e to power 4x, x plus 1. Any question? ام زارا کولومی دوم الیمینیت اکی اوش تدانی کوتمان زیرو فانکشنک yes لا second derivative 2 the third derivative 3 anything else yes جاري yes or جاري step up so the first one you are going to find m yc let me call yc auxiliary solution second one depends on the solution depends on the solution that I got. I'm going to use variation. Depends on here. Okay, dears? Then variation W, W1, W2. Now it's time to find U1 and U2. What was U1 and U2? I don't know. You can check the book. It writes like that. U1 prime of X is equal to W1 over W. Clear? So I'm going to bring the results that I got over W1. Where's W1? Minus X e to power 4. Clear? Hello? And U2 is equal to what? W2 over W. What was W2? Now, I know there's elimination. Then U1 prime will be minus X squared minus X. Am I right? How about U equal to what, Kaka? Integral, thank you. Yes. We are going to find U1x. I c is equal to what? I c is equal to integral of minus X squared minus X by, of course, dx. And I will get what? Minus X to power 3 over 3 minus X to power 2 over 2. Am I right? Clear. How about y2 is equal to what? Huh? y2. Let me check. Sorry, u2. u2 is equal to what? Integral of here. So it's equal to what? كامل يوكان بس ليه تكتر معنى لا حلقان على شيء على u1 prime u2 prime دوزيتو كسانة جيبه شيء على u1 prime u أكاتا w1 over w clear u2 prime أكاتا شيء أكاتا w2 over w divide كيتو دستكه أو تعطيك شوني باش تو prime دستكوتو عتا derivative أي شيء اللي بكيبو u دستكه هس شيء mention أبد شيء بكين integral ورقرين so integral for both sides integral era integral era so you'll get what integral x square root x yes just u تا clear تعطيكيشن كسيت هنا قاعد أني كوسن كاكا hello good W1, W, okay, so now I say I will get YP, particular solution. What's equal to what? Look at here. هانی که کردم بر چاره. Look at here, look at here, look at here. باید چکش که اینو زنیم. اما U2 اما U1 yes راسته اما U2 جاریه yes. So I'll get what? I'll get what? And still, if you remember, YC, if you remember, YC, we see is equal to what? C1 e to x plus C2x e to power 2x. Do you remember that? Hello? Now I say YP equal to, and instead of C1, I'm going to use U1. So I say minus x cubed over 3 minus x squared plus 2 e to power 2x plus x e to power 2x. And instead of C2, I'm going to use U2. I say x squared over 2 plus x. Is that clear for you, dears? Shall I repeat it? Yes. In the auxiliary solution, we say we have that one because m equal to 1 to 2 and it was m1 and m2 repeated. So we have a c1 e to x, c2 x e to x. Now after finding w1, w2, u1, u2, I'm going to use, instead of C1, I'm going to use U1. Instead of C2, I'm going to use U2. So here's U1. Here's U2. Is that clear now? Tears? Okay. Now, طبعا maybe there's a, I think there's a common factor. You can find them, whatever you want to do it with them. If you multiply, you will get what? Yp will be minus x3 e to power 2x minus x squared 2 e to power 2x plus x cubed over 2 e to power 2x plus x squared e to power 2x. Then you will find the common denominator, and you will, by the end, you will get WP like that. 1 over 6, 1 over 2. X cube minus boom plus both. Tamam. Any question? Just find denominator, common denominator. Yes. Parla magajar. You got it, yours? Hello? Good. Now, your y general solution is equal to yc plus yp. Look, like a train. So I'm going to write C1 e to x plus C2 x e to power 2x, then plus x cubed 2x x squared 2 e to power 2x. Is that clear? This is the general solution for what? For higher order non-homogeneous ordinary differential equation. You ask me about the application. We have many applications in your field in the real life. For example, the cloud, how they distribute. If you are doing the smoking and there's a smoke is going to, you can use that one. In the field, later inshallah in advanced calculus, you will get it. When you say that the differential equation is exact, if you translate it to physics, to the real life, you say this is the conservative fields. What do you mean by conservative fields? The field that they are not losing any energy. For example, this room can transfer the energy, but is there any possibility to lose it or not? So how we know this field is conservative or not? This room is conservative or not? So we are going to distribute. So we have many applications. We have a vector field in the plane, airplane, whatever we want. We have many. But maybe in here I cannot show you because we are in the such primary level for the differential equation, really. Because later on you are going to the deeply, you'll see we have a wave equation, heat equation, all of them is differential equation. So if you like it, you can search on it. Clear? You got your answer? Good. Now, it's your turn to help me. Look, sometimes the equations look like very difficult, but really, when you are using them, you see it's not like that. So, let me go to here. Yalla kaka, help me. How we solve that one? First step. Standard. We need to what? We need to divide, right? We need to divide by 4. Why? Because we say that here should be 1. So that's why is that clear, dears? Now I have a standard. Second, don't look at it and read it, think about it. Second, m, thank you. So m square, well done, m square plus 9 equal to 0. So tell me m1 and m2 is equal to what? Is equal to minus 3. So m is equal to what? Clear? Sorry. Tamam? So let me guess. Where's alpha? Where's beta? So e to power alpha x c1 cosine beta x c2 sine beta x. Am I right? Hello? E to power 0 equal to what? 2, 1. So by default I will get what? yc will be c1 cosine 3x c2 sine 3x. Is that clear? That was second step. How about third step? Just memorize it, yes. And remember, think about it. W, you are right. Exactly. So W equal to what? Cosine 3x and sine 3x. He is right. So derivative, right? Derivative of sine, cosine, sorry. How about here? Is that clear? You multiply by the angle. Good. W1. Later on we are going to find it. Yalla. W1 is equal to what? 0, 1 over 4 cosecant 3x. Am I right? Maybe you forget. Go to it. Why? 1 over 4 cosecant 3x. Sine 3x. 3 cosine 3x. Is that clear? W2. Later on you will find it. No worries. The same. You're right. So cosine 3x minus 3 sine 3x, 0 and 1 over 4 cosecant 3x. Maybe the students that they are not good in mathematics, when they saw sine, cosine, secant, they will leave it. Believe me, it's easy. Just try to do it. So W equal to what? Yalla. Let me go back. Let me check. I don't know really. Equal to what? Here multiply here, there multiply here. Yalla. Cosine multiply cosine. 3 cosine square. Am I right? Minus plus 3 sine. So I'll get what? I get 3 by common orgram. Hello? Yek, you are right. So I'll get what? 3. How mu cosine sine change to what? 2 numbers, to 1. How about W1? Yalla. Zero minus. How much here are you? Why? Sorry for the wide word. Yalla. W1 me what W1? Oh, W1. Yalla. 1 over 4. So 0 minus 1 over 4 cosecant 3x sine 3x. Cosecant I got that is equal to what? 1 over what? Affirm. 1 over sine. تمام. So sine and sines go. I got what? W1 equal to what? Minus 1 over 4. دبي نساقي بيرجوتو. Write the notes. So minus 1 over 4. Right, cosecant is equal to 1 over sine. Second equal to 1 over cosine. You saw that one many times. Is that clear, dears? I know I did it quickly, but you saw all this one. How about W2? Yalla. 3 cosine sine. Sorry, here we are. Cosine is equal to 1 over 4. Let me write like that. Sine 3x, cosine 3x. Do you know what did I do? You didn't know? Okay. Sine. Tamam, direct one here. Good, so you got it. Tamam, equation minus 0. Why? Second diagonal is minus 0, so I don't need to. Got a W1, W2. Okay, now that was step number 3, right? It was third step. How about fourth step? One year to die WU. So U1 prime, I say equal to W1. Am I right? U طبعا قاعدة عن U1 هذا أكثر يا دوي دوز من قينا يجدي. U2 prime equal to what? Huh? W2 دقيقة. I want to charge my computer. Day dears, do not sleep. After that one, you will take a rest, long rest. Yalla. Day kaka. W2, W2 over W, right? Hello. W over W. Yalla. W2 over W is equal to what? 1 over 4. W. Yes, 3. So 1 over 12 cosine 3x sine 3x. Am I right? Good. What else? Integral. You are right. We needed the u. So u equal to what? U1 is easy. U1 of x is equal to minus 1 over 12x. Is that right? How about U2? U2 is important. It's easy actually. 1 over 12. Yeah. How we solve that one? Cosine 3x sine 3x dx. Put your mobile away. Yalla. Is equal to what? Exactly. So I say what? Derivative. So I wanna y minus. You don't need a minus. So I want a 3. Is that clear? So it's equal to what? 6, 3 ln of sine 3x. Is that clear again? Yes. Now I got yp, which is equal to 1 over 12 1 over 12x. What else? YC Chibu. Let me write down YC for you again. YC, it was, if you remember, C1 cosine 3x, C2 sine 3x. So YP will be what? Huh? Minus 1 over 12 x cosine 3x plus 1 over 36 ln of sine 3x multiply sine 3x. Not your lina multiply كيتشكو lina that is outside. So generally you can see from here this YW, this is Wronskian, this is W1, this is W2, and here is YP that we got it. Is that clear, dears? How about Y? We see that Y equal to what? YC and YP. Then I will get what? This is YC, this is YP. It will be your general solution. It's not hard, but really long and need works. So do not forget to solve it. That example is not included because why? Because we cannot find the value of the integral. Sometimes the integrals will stuck you. You cannot solve it by any methods. Really, we cannot solve that one as a human. We need a computer or like approximation. So you can see he solved like what? YC, leave it like that. So generally, the example is not included. Your classmates asked me about how many W we have. I told you depends on the orders. You can see, for example, if you have a higher order, how we solve it? Your matrix will be like that. Look, W, generally you know how to find W. First derivative, 1, 2. So first derivative, then second derivative. So W. Now how about W1? We change it to 0, 0, F. The other remains. How about W2? How about W3? You got it here? You can see from here the functions and the first derivative and the second derivative and how to find W. Maybe in the exercise you have it, I don't know, I'm not sure about it. But generally try to solve those examples that we mentioned. Is that clear, dears? Any question, any things?